Hello friends, welcome to my YouTube channel Navigator Updates. If you don't know me, I am Rakesh Negi and I am an aviation enthusiast. Today we'll be discussing about electrical solenoids and relays. So let's start. Solenoids and relays. So friends, first let's start learning about the solenoid. So what is a solenoid basically? It is an electrical device which can convert the electrical energy into a linear displacement. So to understand this, let's first understand the construction of a solenoid. I mean to say, what all components does a solenoid have? Okay, a solenoid has an inductive coil and a core, which is also called as armature. Okay, usually in a solenoid there is a split type core. So now let's understand here. So as I said, it consists of a core. So suppose this is the core, okay, and also I have said that it has a split type core. So suppose this is a split type core. This is one core, friends. Okay, this is fixed core. Okay, this is what core? Fixed. So I'm just shading it. So which core I have drawn right now? Fixed core. Okay, also friends, it has a movable core. Suppose this is the movable core. The fixed core and the movable core, they are separated by means of a spring. Okay, suppose this is the spring. I'm just drawing the cross sectional area. Okay friends, okay, so a spring is there in between the fixed core and movable core. Okay, so this one is the movable core. Okay, now this movable core, I'll just draw these type of lines. So friends, I'm drawing these green lines so that you understand the difference between fixed core and movable core. So this is a control rod like this. Okay, a rod is there. So this control rod, it used to connect the movable core to the external. Okay, and suppose here there is some mechanical linkage which I want to connect. Okay, so this can move up and down. This part, the part on which I have drawn these green lines, okay, this core can move up and down. Okay, in normal state the spring will push it downwards. Okay, that means the spring force has dominated in normal condition. Now what I have told you till now is this is a fixed core and this is a movable core. So I'll write here fixed core and here this is movable core. Okay, and outside of this, what do we have? We have windings. Okay, so the winding will be outside this core. So suppose these are the windings. So these circles, they represent the cross sectional area of the windings. Do not think them as zeros. Okay friends, so these are the windings which are wound. So like this they are wound. I am just showing the cross sectional, that's why you can see them as circles. So what are these? These are the windings. This side and this side are the windings. Okay, and what is this? Movable core and fixed core. And what is this? Mechanical linkage. Okay, so that I can link this movement. So when the core will be moving, this mechanical linkage can be linked to any unit such as the valves, switches, okay, anything whatever requires linear mechanical movement. Okay, as I have told you in the beginning friends, the solenoids are the devices which can convert the electrical energy into the mechanical movement, that is the linear mechanical movement. So let's understand how does this solenoid operate. Okay, before learning about the operation of this solenoid, we should know some basics. Like suppose there is a coil. okay, and in this coil I give a current. Suppose I represents the current. So when I supply current to this coil, it will produce a magnetic field around it, right? So like this it will produce a magnetic field. And if in this case I keep a soft iron bar like this, okay, near to it, what will happen? This will be pulled towards the coil, okay. It's because of the magnetic field effect of the coil, okay. So same thing happens in the solenoid. So let's start learning about the operation of the solenoid. In the solenoid, when I give electrical supply, that is current, to these windings or coils, what will happen? These coils will produce magnetic field, right? So this magnetic field, what does it do is, it will magnetize this core, okay. So the fixed core and the movable core, both of them will get magnetized, okay. And when they get magnetized, note that friends, these core can be made of soft iron or steel, okay. So when these core get magnetized, this will be pulled upwards, okay. The movable core will be pulled upwards. That means it will be attracted by the fixed core. Why? It's because when electrical supply is given to the coil, the magnetic field used to magnetize the fixed core and movable core in such a way that both of them have different polarities. That means fixed core and movable core will have different polarities. And we know, well friends, when different polarities are there, they will attract one another. So same things happen here. The fixed core and the movable core will attract one another, and in this situation the spring will get compressed. That means the magnetic force is dominating the spring force. Hence this movable core will move up and some linear displacement will happen, okay. So this linear displacement, whatever has taken place, can be used, okay, or this force can be used for the movement of hydraulic or pneumatic valves or switches or any mechanical unit wherever linear movement is required. So friends, I hope you are clear with the operation of solenoid. Okay, now I'll quickly summarize what is a solenoid, its construction and operation. So what we have discussed is, a solenoid is an electromechanical device. That means it can convert the electrical energy given to it into mechanical energy. Next, how is the solenoid made of? Okay, the solenoid consists of inductive type coils, okay, on which we give the supply and magnetic field is induced, and a core, okay. The core in the solenoid is usually of split core type, okay. Split core means it has two parts. One is fixed core and the other one is the movable core, okay. The movable core is connected by means of a control rod to the mechanical linkage, okay. This mechanical linkage, as I have told you, it can be connected to any valve, switch or any mechanical unit, whatever requires the linear displacement. Next, we have discussed that the core can be made of soft iron or steel, okay, and coils obviously will be made of copper, and obviously there will be insulation, okay. Next, we have discussed about the operation. How does a solenoid operate? Okay, for the solenoid to operate, obviously we need to give some electrical supply, okay. So when we give electrical supply to the solenoid, it goes into its coils, okay, and that electrical supply will cause the current to flow in the coils of the solenoid. So when the current is flowing through the coil of the solenoid, it will produce a magnetic field around it, as like this, okay. So the coils will be producing a magnetic field. That magnetic field used to magnetize the core, the fixed core also and the movable core also, in such a way that both of them will be magnetized with opposite polarity, okay, which will cause them to be attracted towards one another. The fixed core cannot move, hence it is only the movable core which can be moved. So movable core will be moving upwards as it is attracted by the fixed core. When it moves upwards, a linear displacement is caused, which can be utilized for the movement of valve switches and any other mechanical unit, whatever requires the linear displacement. So friends, I hope you are clear with the operation of solenoid. One thing to note over here is, in normal situation, the spring force dominates the magnetic force, okay, and when the system is energized, in that case the magnetic force dominates the spring force. That means the magnetic force will compress the spring so that the movable core can move upwards or get attracted upwards to move the mechanical linkage, okay. So friends, this is all about the solenoid. So what is the conclusion over here? The solenoid is a electromechanical device. Electric energy is converted into mechanical energy. And next point to note over here is, in the solenoid, it is the core which moves, right? Okay, now friends, let's discuss about relays. So what are relays basically? Relays are electrically operated switches. Friends, you must have seen that the electrical switches are generally mechanically operated, as like the light switch in your home. So whenever you want to turn on a light, what you do is you used to put on the switch, and whenever you want to turn off the light, what you do? You put off the switch, right? So you do it manually. So likewise in the aircraft cockpit also, you can turn on and turn off the switches manually, right? But there are some switches which can be electrically operated without any manual action, and those switches we can say oftenly are relays. Okay, so you can say that the relays are electrically operated switches. So friends, I hope you have got the basic idea about relays. Now let's learn about its construction. What does it have? So as like the solenoid, the relay also has a core and a coil. That means an electromagnet is there. Suppose this is the electromagnet, this is the coil, and in this coil core is there. Okay, I'll just keep it within a casing like this. So this is the electromagnet, and its terminals are here, two terminals which are here, one terminal here, one terminal here. Why are these two terminals given, friends? So that I can give supply to the coil, and the coil which is having this core within it will magnetize the core. Okay, and hence this will become an electromagnet. That means the relay also consists of an electromagnet. Next, there are contact points also. Suppose this is one of the contact point, and this is the other contact point. I want both of them to be closed. Okay, generally when the contact points are open in the normal state, those type of relays are called as the normally open relay. Okay, and if the contact points are closed in the normal state, then in that case that particular relay is called as normally closed relay. Okay, next, suppose this contact point, okay, this is connected to a conductor, and here I have fixed some bolts, and this is the bolt, and this is the wire which is connected to it. Okay, this is the wire. Next, this contact point, suppose, is connected to this arm. Okay, and here I have a plate called as the armature. Okay, so this is the armature on which I have drawn hatching lines, and this length is connected to a pivot point. Okay, and this is another lever on which I connect a spring. Okay, why is this spring there? So that when it is holding its tension, it will cause this contact point to be in the open state. Okay, and if I want this contact point to come down, then the spring will extend. Okay, will have expansion. Okay, so when this will have expansion, this will move down, and this contact will touch this contact. So the upper contact will touch the lower contact in that case. Okay, next, so I'll extend this, and this also is connected to a base or mounting like this, and there is a wire. Suppose this is another wire. Okay, so this is a wire, this is also a wire, and this wire is connected to this path, and it is going like this through this contact. It is going, and by means of this contact point here the circuit is open. Okay, from here again, if both the contact points touch one another, the connectivity will be linked like this to another wire. That means both the wires can be connected if these 2 points touch one another. Okay, so how will these 2 points touch one another? So this is placed within a casing. Okay, I'll blot out these terminals, and this thing is called as the relay. Okay, so this inside this casing, this unit is called as the relay, and this is called as the armature. ARMATURE, armature, and these two are the contact points. And what is this? This is the electromagnet. Okay, so I'll quickly summarize about the construction. In the construction, we have discussed that the relay consists of an electromagnet, the armature, and the contact points. In normal state, the contact points are open. That means if the armature is away from the core, that particular type of relay is called as the normally open type of relay. And if both the contact points are closed in the normal state, that means the armature is towards the electromagnet, then that type of relay is called as the normally closed relay. Now friends, let's discuss about the operation of the relay. So how does it operate? So when I give electrical supply to these terminals, current will flow in the coil of the relay, and this will magnetize the core. So when the core will get magnetized, or I can say when the relay gets energized, what will happen is it will produce a magnetic force which will pull this armature downwards, okay, or I can say it will attract the armature. So when the armature will be attracted by this core, what will happen is the armature will come here. So armature will settle over here like this, okay. So suppose this is the armature, so this will bend like this, okay. So this is the armature, so I have drawn it properly. So when this bends, so that time this will be, both the points will be touching. So this contact point which is on top will come down and touch the lower point. So both the contact points will close. When both the contact points close, then the circuit is completed. See, from here, from this wire, the current was flowing like this. It will go via means of this path. From here, it will be connected to this circuit. That means the contact points, when closing, closes the circuit. Okay. So friends, how did these two contact points close? Because of the armature getting attracted by the core. Okay. So likewise, not only just open, suppose if the system is in closed state, okay, that means if both the contact points are closed in the normally closed state, when the core gets energized, it can also repel the armature so that the contact points can open. Okay. So friends, I hope you are clear with the operation of the relay. So I'll quickly summarize the operation of relay now. In a relay, what happens is when you give the supply, the core gets magnetized, and because of which the armature is attracted towards it. As the armature is getting attracted towards the core, the contact points close, and hence such type of relay is called as the normally open relay. Okay. Why normally open relay? Because in the normal state the contacts are open, so it is closing only when the relay is getting energized. Okay. So likewise, another type of relay can be there in which the contact points are in the closed state, okay, in the normal situation, and when the system will be energized, that time it will repel the armature and cause the contact points to open. Such type of relay is called as the normally closed relay. So friends, this was about the operation relay. So friends, I hope you are clear with the operation of the relay. What is the conclusion over here? The conclusion is, in a relay, okay, it is the armature which moves, okay, not the core. And what did we learn about the solenoid? In a solenoid, it was the core which was moving. So what is the overall conclusion? In a solenoid, the core moves, and in a relay, it is the armature connected to the contact point moves. Okay, that means the armature moves, not the core. Okay, now let us discuss configuration of relays. What we'll learn? Relay configuration. So in relay configuration, the simplest form is called as SPST, single pole single throw. Okay. Now what is this SPST, friends? Single pole single throw. This example is the best explanation for SPST, single pole single throw. Now what does single pole means? Single pole means this link, okay, which will cause the circuit to be closed. So this initial link is called as the pole, and throw means the number of circuits that can be closed when the relay is energized. So how many circuits were getting closed when this relay was getting energized? Only one. See, only one circuit. Hence this is called as the single throw. Okay, so let's learn about more configurations in terms of symbols. Okay, relay symbols. So I'll use this space. Okay friends, if I ask you to draw single pole single throw, so what I'll do is I'll draw a coil like this. Okay, a core like this. This is the armature, and these two are the contact points. Okay, that means when this will be energized, this contact will close. Okay, so this is called as the single pole, and the throw is also single. Now the other configuration is single pole double throw. So if I ask you to draw single pole double throw, so this is single pole single throw. Now let's learn about single pole double throw. Okay, so single pole double throw, I'll just draw a single pole. Suppose there is a single contact point over here and there is a double throw. So two circuits can be closed. One circuit is connected to this, another circuit is connected to this. So two circuits are here, and this is the armature, which will move and the core will be energized. Okay, that means when this relay will be energized, this armature contact can get shift here. Okay, so when it is in this position, it is closing one of the circuit, and when it will be energized, it will move here. That means it will connect to another circuit. That means two circuits can be connected to this armature. Hence this type of relay is called as the single pole double throw. That means double means two. So let's understand the meaning of SPDT, single pole double throw. Single pole means this one contact point, and double throw means this 2 points. What do they represent? They are connected to two separate circuits. That means two circuits can be controlled using this relay. That is called as the single pole double throw. So friends, I hope you are clear with the single pole double throw. Next, let's learn about double pole double throw, that is DPDT. Suppose this is DPDT. Okay, so double pole, so just draw double pole. One contact is here, this is single pole, another contact is here. Okay, you have made two poles, and just draw double throw. So for this contact point you have two throws. So both the contact points are connected. This contact point is connected to one circuit, and this contact point is connected to another circuit. So likewise for this pole, the circuits which can be controlled are this one and another circuit by means of this contact point. Okay, and where is the armature? Here. And for this, where is the armature? Here. And both of them, they are connected to the core electromagnetic effect by using this coil. Okay, that means in this double pole double throw, how will the relay behave? So when I energize this, it will electromagnetize the core. When the core gets magnetized, it will shift both of these armature together to the other point. Hence this type of relay is called as the double pole double throw. Okay, let's try another configuration. DPST. Is that type of relay possible, friends? Double pole but having single throw. So means there are two poles but controlling one throw. So can such relay exist? Yes. So I'll show you, friends. Double pole single throw. Okay, so for DPST, as the name says, double pole. So let's make double poles. So these are the contact points which are representing the poles. And what about single throw? So single throw, as it says, so just draw a single throw over here. For this pole, this is the single throw. Okay, and what is the armature? The armature is here, like this. So this is the armature, this is also the armature. Both of them, they are controlled by single action to this coil of the electromagnet. So how does this double pole single throw operate? When the relay will be energized, it will attract both these armatures together and they will close like this. Okay, together. That means in one single action both the circuits will be completed. That is the single throw. Hence such type of relay is called as the DPST, double pole single throw, this one. Okay, so friends, I hope you are clear with the relay configurations. So what is relay configuration? Relay configuration is about the poles and throws. Poles represent the link and throw represents the number of circuits that can be linked using a single relay operation. Okay, so in relay configuration we have discussed about SPST, single pole single throw, SPDT, DPDT and DPST. So these are all the relay configurations. So friends, these are the relay configurations which are commonly used in the aircraft. The simplest form of the relay configuration is SPST, that is single pole single throw. Okay, so friends, there are two important terms which you should know, which we have already studied, but I have not told you those terms, and you know about those terms. Those terms are pull in voltage, and number two is drop out voltage. So friends, what is this pull-in voltage? Voltage at which the armature is attracted by the magnetized core is called as the pull-in voltage. And what is dropout voltage, friends? Dropout voltage means when the contacts return to their relaxed positions, normally closed or normally open state, okay, that particular value of voltage is called as the dropout voltage of the relay. So friends, I hope you are clear with the terms of pull-in voltage and dropout voltage. So let me give you a quick summary of what we have discussed today. We have learned about the solenoids and relays. In solenoids, what did we study? We studied about its construction and operation. We studied that it has a core which is of split type. That means it has a fixed core and a movable core, and it has the coil. Okay, and how does it operate? So when the solenoid is energized, it is the core which moves. That means the magnetic force used to dominate the spring force, which will cause the movable core to be moved, and this will be used for operating the mechanical units, whatever requires linear displacement. Then we have discussed about the relay. In relay, we have discussed about its construction. That means it also used to have a core and the contact points in armature. So when supply is given to the relay, what will happen is it will energize its core. That means an electromagnet will be produced which will attract the armature or repel the armature. Okay, and accordingly the contact points will open or close depending on the type of relay. And after that, we have discussed about the relay configurations, that is SPST, SPDT, DPDT and DPST. And after that, we have discussed about the pull-in and the dropout voltage. What is pull-in voltage, friends? Pull-in voltage is that particular voltage at which the armature is attracted. And what is dropout voltage? Voltage is that particular specified point where the contacts or the armature return to its relaxed state. So friends, the overall conclusion to note here is, in solenoids the core moves, and in relay the armature or the contacts move, okay, not the core. So friends, I hope you are clear with today's topic. I'll come up again with such interesting topics in the next session. Till then, enjoy learning this topic, and thank you.